Hello friends and welcome to my channel and good luck with your interesting learning. Today we are going to talk about how to find the weight distribution of a vehicle. Weight distribution have a huge effect in the performance and handling of a vehicle. So we are going to concentrate in four-wheel vehicle as well as three-wheel vehicle, which is related to bicycles and auto rickshaws to four-wheel cars. So let's study.
This figure shows a three-wheeled vehicle. This is the front side, so the front axle will be here, and this is the rear axle and both rear wheels. You can see that CG represents the center of gravity, and the center of gravity is shifted from the longitudinal axis by an amount c. You can see that here the center of gravity is shifted by an amount c from the longitudinal axis of the three-wheeled vehicle. And consider R1 is the reaction at the left side rear wheel when we look from the aft of the vehicle, and RR2 is the reaction at the right rear wheel when we look from here. And A is the wheel track, which is the distance between the center of the wheel plane in a same axle. And here you can see this is the lateral view. F represents the front side and R represents the rear side, and RF is the reaction at the front wheel axle. And because we are considering a three-wheel vehicle, so the front side will have only one tire, so there will be one reaction only, but in the rear axle there are two wheels, so the total reaction at the rear wheel or the rear axle is the sum of RR1 and RR2. And B is the wheelbase, which is the distance between the center of the front tire and rear tire, and H is the height of center of gravity from the ground, and the weight W acts through the vertical because the vehicle is in a horizontal plane, and there is no gradient angle as the vehicle is not going for a gradient here. So let's find how to find the distribution of weight of a three-wheeled vehicle. So for that we have to commence by taking moment with respect to the rear axle of the vehicle. As you can see here it is the rear axle, so by taking the moment we are taking the clockwise moments as positive and the counterclockwise moments as negative. So the clockwise moment here is the moment that is made by the reaction at front wheels, which is RF into B. So it will be the magnitude of the clockwise moment, and the counterclockwise moment is the moment that is made by the weight of the vehicle, and its magnitude is W into L because the distance of the center of gravity from the center of rear wheel or from the rear axle is L, so the magnitude of counterclockwise moment is WL. So we can write RF into B minus WL equal to 0, so we can write RF B is equal to WL. From here we can write the equation for RF as RF is equal to WL by B. And now we are going to the second step. In the second step we have to take the moment with respect to the central axis, which is the longitudinal axis that I shown earlier. So we have to take the moment with respect to the central axis or the longitudinal axis of that vehicle. So we are taking moment with respect to this point. So here also we are taking the clockwise moments as positive and the counterclockwise moments as negative. So the clockwise moment is the moment that is made by the reaction at the left wheel, which is RR1. So it have a magnitude of RR1 into A by 2 because A is the wheel track. So we are taking the moment with respect to the center of the vehicle or at the longitudinal axis. So this distance will be A by 2, which is the half of the wheel track. So the magnitude will be RR1 into A by 2, and the RR2 will make a counterclockwise moment, so it will be in the opposite direction. So RR1 minus RR2 into A by 2, we can take RR1 and RR2 RR1 minus RR2 into A by 2 because A by 2 is common here, and there is additional moment that is made by the weight because the weight is acting through the center of gravity and it is at an offset C. So it is also making a counterclockwise moment here, so it will act like this. So it is also have the magnitude W into C, and it will be with the minus sign because it is acting in the counterclockwise moment. So we can write WC plus RR1 into A by 2 minus RR2 into A by 2 is equal, so because it is at equilibrium, so we can write WC equal to RR2 minus RR1 into A by 2, and from here we are taking the reactions in the left hand side, so RR2 minus RR1 is equal to 2 WC by A, so we can write it as like this. So we are putting this as equation number 2, because the equation number 1 we have already found about RF, which is W L by B. And the third step, we are going to take the moment with respect to central axis of front wheel, which is the uh, front axle. So we are taking moment with respect to this point. So here we are also taking clockwise moments as positive and counterclockwise as negative. So the reaction of rear wheels are making a counterclockwise moment, so it is negative, and the weight is making a clockwise moment, and we are considering that as a positive moment. So the magnitude of moment that is made by the weight of the vehicle is W into B minus L. Because this is the offset of weight action of the force that is due to the weight of the vehicle that is acting through center of gravity, so this magnitude is W into B minus L because this is the offset. And the magnitude of moment that is made by the rear reaction at the rear wheels is RR1 plus RR2 into B, which is the wheelbase of the vehicle. So we can write W into B minus L minus RR2 plus RR1 into B. So this will be is equal to 0 because this is in equilibrium. So we can write RR2 plus RR1 equal to W B minus L by B, and we are considering this as equation number 3. So our prime objective is finding distribution of weight, or the meaning of the distribution of weight is the equation for reaction at front wheels and reaction at each rear wheels. So we have to find RF, RR1 and RR2. So we already found the equation for reaction at front wheel, which is RF, so we have to find equation for RR1 as well as RR2. For that we have two equations, which are equation number 2 and 3. So by adding equation number 2 and 3, we will get the value of RR2 here. So first we are going to add equation number 2 plus 3. So by doing that we will arrive at like this: RR2 minus RR1 plus RR2 plus RR1. So RR1 will get cancelled in the left hand side, or LHS. So in the right hand side it will be W into B minus L by B plus 2 WC by A. So the weight W is common here, so we are taking it in the outside or back and putting these two sides in a bracket. By doing that we will get 2RR2 is equal to W into B minus L by B plus 2C by A. So from here we can write the equation for RR2 as RR2 is equal to W2 into B minus L by B plus 2C by A. So we have found the equation for RR2. So now we have to find the equation for RR1. So from here we can see that if we subtracted equation 3 from 2, sorry, equation if we have subtracted equation 3 minus equation 2, we will get the equation for RR1 as well. So we are going to do equation 3 minus equation 2. So by doing that we will arrive at RR2 plus RR1 minus RR2 plus RR1. So the RR2 will get cancelled and we will arrive at 2RR1 is equal to W into B minus L by B minus 2C by A. From here we can write RR1 is equal to W by 2 into 1 minus L by B minus 2C by A. And the total weight of the vehicle will be equal to RF plus RR1 plus RR2. So we have found the distribution of weight for a three-wheeled vehicle. So the equation for RR1 is W by 2 into 1 minus L by B minus 2C by A, and equation for RR2 is W by 2 into B minus L by B plus 2C by A. And similarly for RF is WL by B. Now let's do the same for a four-wheeled vehicle. So for this we are considering the weight distribution, or the center of gravity of the vehicle is coincide with the longitudinal axis of the vehicle, so that there is no offset between the center of gravity and the longitudinal axis. So for which means that the reaction at uh, front wheels, which has the front left wheels and front right wheel will be equal, and similarly for the rear axle, the reaction at the left rear wheel and right rear wheel will be equal, so it will be equally distributed in the two tires of each axle. So for the we only have to find the reaction at front axle and rear axle only for finding the distribution of four-wheel vehicle. So for that we have to find the force. For that, first we are resolving the forces vertically, and it is in equilibrium, so sigma total sigma Fv is equal to 0 by summing up. So we can write there are three forces, and the weight of the vehicle W is equally distributed to the front axle as well as rear axle, so we can write W is equal to Rf plus Rr. Rf is the reaction at front wheels and Rr is the reaction at rear wheels. So first we have to find the equation for RF. For finding the equation for RF, we have to take moments with respect to the rear axle. So by doing that, we are considering the clockwise moments as positive and counterclockwise moments as negative, just as how we have done before. And the clockwise moment if is made by the reaction at front wheels, and it is having a magnitude of Rf into B, where B is the wheelbase, the distance between the center of front wheel as well as rear wheels. So the clockwise moment is Rf into B, and the counterclockwise moment is made by the weight of the vehicle, which is W into L, as you can see here. The L is the distance, this is the distance L. Sorry for the mistake. So we have resolved the moment with respect to the rear axle, so we will get WL minus Rf is equal to 0. So we can write Rf equal to WL by V, and we have found the equation for Rf. So we have found the distribution of weight at the front axle, and we have to find the distribution of weight at rear axle. For that we have to substitute the value of Rf in the equation A. So from here we can find the equation for the reaction at the rear wheels, or the distribution of weight at the rear axle. So by doing that we can write W equal to WL by B plus RR. So we have to find RR. So it will be W into B minus L by B, because we can, from here we can write R is equal to W into 1 minus L by B, so it will be B minus L by B. So we can write the reaction at rear wheels as R equal to W into B minus L by B. Hope you understood how to find the distribution of weight for a three-wheel vehicle as well as four-wheel vehicle. Hope you enjoyed the video and learned something new. Don't forget to subscribe to my channel for getting updated videos about engineering and vehicle dynamics. Please don't forget to subscribe. Thank you.